All right, welcome back to the second part here on creating your own functions for import. So last time, I'm going to go ahead and run this import. Last time we went through this starter file and we talked about defining matrices, we talked about the dot product, and we talked about the metric tensor. And we did one quick example for tin, which was a tetragonal system. So it had a square base and stretched in the third axis. So A equals B, and then C is different, and then all angles are 90 degrees. So we could calculate that for white tin, the simple calculation since all the angles are 90. But we also wanted to do this in general using the G matrix. So we're looking at the square root of the determinant of the G matrix. So what we want to do now is to go ahead and write a function to perform this calculation and return the volume of any unit cell given the ABC and the alpha, beta, gamma parameters, okay, lattice parameters. All right, so let's go ahead and we can write out the G matrix. And so remember, here is the form that we're looking at: a squared, AB cosine gamma, AC cosine beta, etc. So this is going to end up being another NumPy array. And so we're going to get sort of just the form in here. So let me go ahead and just kind of get the form. All right. Now help, I think maybe to keep things a little bit easier to see as we're typing in, I'm just going to add some return keys here just so we can kind of see what this is looking like. Okay, so we're going to add that first row, second row, third row in here, and we'll go ahead and close our array. So let's go ahead and get that in. So for example, the first row here, I'm going to have A times A, okay? Or you could have just written that as A squared if you like. But then we're going to have A times B times the cosine. All right, now the cosine's not in standard Python, it's in NumPy again. So we're going to use NumPy cosine, okay? And that one was gamma. So I'll go ahead and use gamma. And then we have A times C times NumPy cosine of beta. Okay. And then we'll go ahead and we will add the rest of these in here. So let me go ahead and get those. All right, I got those in. Got to fix this. These indents, they do need to be correct. All right, so there's my NumPy array. And if I was to go ahead and try and run that, I'm going to have a problem because NumPy and arrays can only handle numeric values, not variables. So we can use something called SciPy, and we'll do that later so that we can use variables. But I'm going to need to put values in for these if I'm going to kind of test this array and see what things look like. So there may be multiple ways of doing that. I guess I could write this as a function right now. So I guess let's go ahead and do that. So we'll call this, let's go ahead and write this as a function. So this will be a function called, let's see, G matrix. Okay. And my function needs parameters A, B, C, alpha, beta, gamma. It's a definition, so since it's a definition, I need a colon here. And then when I write definitions, remember, once I hit return, everything needs to be indented. So I have to actually indent my my array here. This is going to have to move over as well. All right, and then, so let's call this inside of here. This will be calculation we're running, so that's G. And then I'm going to return G. All right, so that's my definition. So I just ran it with Shift Enter. And let's see if things are actually working correctly. So G matrix, right? That's my function. And let's go ahead and just put in some numbers here. 1, 2, 3. Let's make the alpha, beta, gamma equal to 90 degrees. So what I've defined here would be then an orthorhombic unit cell, right? A, B, and C, they're all different. All right, so I get an error return. Sorry, this is a habit from Mathematica where all functions are capitalized. In Python, they are lowercase. And I also should have noticed the color, right? Whenever it's a known function, it does show up green for me. So let's try that again. And there is my G matrix. All right. Now, is this correct? That's part of what we were doing was in our testing. And if we go back and again look at that G matrix, we have AB cosine gamma, cosine beta, cosine alpha. These were all 90 degrees, so these terms should all be 0. And I'm not getting 0 here. So something's not right. Okay. And so let's go ahead and try and take a look at this separate term. Okay, so this is kind of one way in which you can debug. You got to break things out. You know, I know there's something wrong with all of them, so let's just look at one of them. All right. So I have an AB numpy dot cosine gamma. So let's just go ahead and look at this cosine term, and we said that that should have 90 degrees in it. Right, and A was 1 and B was 2, so if I want I can put that in here too. And let's go ahead and run that. Okay, well I did get back exactly the number that I had here, but it's still an error, right? It should be 0. So what's the problem? The problem is that in most programming languages you will find that things like cosines and sines and tangents all expect radians, not degrees. Okay, so that's my problem. So what we're going to do is, but I still like to put in degrees. I don't want to have to figure out what the radian value is. What happened to my... Anyway, I don't want to have to do that, so let's go ahead and we will try this again. So we've got numpy cosine 90. Okay, again, it's not 0. I want to turn this into radians. Okay. There is a numpy command called there we are, numpy degree to radian. All right, there we go. So within the precision of these floating point numbers, I get something like 10 to the minus 17. So that means 0. Okay, so that's working. I could test some others, maybe like 45 degrees. Right, that should be the square root of 2 over 2, which is 0.7071, so that looks good. 0 degrees would be 1, so that looks like it's working out. All right, so let's go ahead and we're going to have to go in here and change all of my alpha, beta, and gammas inside of this function. Now, I guess rather than have to come in and change all of these, what if I was to do something like this and say alpha is equal to numpy degree 2 radian alpha. So I'm just converting the alpha, beta, gamma 2 degrees before I actually get to my G matrix, all within my function. All right, now let's go ahead and try it. G matrix, 1, 2, 3, 90, 90, 90. All right, so much better. So I've got 1, 4, 9, and then everything else is 0, or in this case 10 to the minus 16. So that looks fine. Looks like things are working. We'll talk later about how to clean this up a little bit and how to make these show up as 0 rather than 10 to the minus 16. All right, so it looks like my function's working and I'm getting the G matrix returned. All right, so what next? So we want to actually find the volume of the unit cell. So the function I want to write then would be something like, let's say volume unit cell. Or if we like things short and we're lazy, we can do volume unit cell, VUC. Okay. So VUC takes A, B, C. It takes alpha. It takes beta. And it takes gamma. Remember, we're using the colon for the defining the function. And now we're going to do the same steps we had in how we defined the matrix up here. So I'm actually going to just grab those. Okay. So I've got all the steps I had before. I'm going to turn them into to radians. I'm going to create this G matrix called G. And now I'm going to go a step further, and I'm going to go ahead and take the square root of the determinant, and remember that uses lin alg. Okay, determinant of G. And I could call this something if I want it within here, and then I will return that volume. So let's go ahead and do that. I'm going to copy this down. Okay, instead of calling G matrix, I'm calling VUC. And I get 6. All right, does that make sense? 90, 90, 90, so that means we've got parallel pipe head, and I have edge lengths 1, 2, 3, so all I got to do is multiply those together. I get 6, so that works. All right. And that is my function to simply return the volume of any unit cell defined by my lattice parameters. And that's what I was trying to do in this particular problem. All right, so what I got to do now is put everything that I need within one cell so that this function can run on its own. All right, and then what we're going to do is test it after I restart the kernel, so I know that there's nothing in memory that is using in the rest of this notebook. That's how I'm going to test it to make sure it's really standing alone. All right, so let's go ahead and just copy this down. So the way I've got this set up, it looks like everything's already in one cell. I don't have to do anything else. So let's test and see whether that's true. All right, so I got it all in one cell. Now I'm going to restart the kernel. So let's go up here to kernel, and we'll go restart. And yes, restart. Okay, so nothing is actually in memory anymore. So I can go ahead and run this. And now let's do my test. Let's go ahead and run it, put some stuff in, and I get an error. Okay, my error says that the name NP is not defined. That's true, right? Remember when we ran this notebook originally, we had to define NumPy, and I never imported it in this function. So what I need to make sure is that my function actually does have the NumPy built straight into it. So let me go ahead and put that in this cell as well. Import NumPy as NP. Okay, I don't want to put it inside of the function because then every time I call it, it's going to be recalling the import command. So I do want that to be outside. I can go ahead and give this module a name. Let's say unit cell volume. And I could give this module some description if I want it, just to make things a little bit cleaner. So there we go. So we got the unit cell volume, and we're told, what it is and what it's doing. I've got my definition, and I've got my return. All right, so let's test that again. So again, kernel, restart. Okay. Now I'm going to go ahead and run this, and run this one. Okay, so it works. Okay, so all I needed was this import command for this to stand alone. All right, so the next step then, now that it's all in one cell and it's a standalone, we're going to go ahead and copy this now into a text file with the extension py for Python. One of the packages that works pretty well for that is Notepad++. I'm going to take all of this and I'm going to just copy it into Notepad++. Boom. All right. So this is Notepad++ is nice because it's expecting code, so it keeps your indents and all of that. It's a text file. If you just paste this into Notepad, one of the troubles that you'll run into is when you save it, it will automatically save with a text extension .txt when you need a py extension, and so you'd have to go into your file manager and change the extension manually. But here we can just go ahead and save it. So let's go ahead and save it. Let's see here. I'll just put it, let's put it, you should save it actually where your file is that you're working on. So this is, my file's called Video Lecture 1 Starter. So I want to make sure that I'm saving it in the same directory. So make sure you do that. All right, but now I can give it a name. So let's give it a name as like my function. I already have one called that, so I don't want to overwrite it. I'm going to call it my function2.py. All right, so I've got it saved. I can go ahead and close that. I don't need that anymore. And now I've got my final test, which is to import it and see if it works. Okay, and this is my command. All right, so I don't want to do it in this notebook because I've already run it. It's already defined. So what I want to do is I want to go ahead and create a new notebook. So I'm going to go ahead and click on File, New Notebook, Python. Okay, this is a brand new notebook. So if I tried to do volume of the unit cell and I put in some numbers here, all right, it's going to tell me it doesn't know what that is. All right, well, let's go ahead and import it. Let's go and import my file, which was my function 2, I believe. I don't remember if I had an underscore here. I guess we're going to see in a second. So I'm going to go ahead and import my function 2. If I want to give it a short name, so I don't have to type all that, let's just call it my. Alright, didn't find it, so it's probably because I need this. Yeah, so I called it my function 2. I also put an underscore. So just the name of your file, you don't need the extension, you're only putting that. It's already looking for the py extension. All right, so presumably that's imported. Everything is good. So I'm going to go ahead, copy this down and run it again. Oh, sorry. Yep, so remember when we import NumPy as NP, whenever I used a command or function inside of NumPy, I always had to put np dot whatever my command is. This is the same exact thing. I've now created a package, if you want. That's the file name. And then within that file name are going to be functions. So my function is called VUC. That happens to be in there. And I can put a lot more in that file. So when I call this, I have to tell it to grab this import as my, and then go ahead and grab that function. There we go. So it works.